What if your code could talk back? Until now, your scripts have been one-way conversations, sets of instructions that run from top to bottom. Today, we change that by teaching your code to react to the person sitting at the keyboard. Without a way to listen to the user, a program remains isolated. It performs the same exact actions every time it runs, regardless of who is using it or what they actually need. Look at this interface. Whether you are logging into Instagram, typing a delivery address into Swiggy, or entering an ATM PIN, real-world software relies completely on collecting outside data. If the app can't ask you for information, it can't function. Today, you are going to write code that asks for that information. Open your preferred Python coding environment. We are going to build a dynamic student introduction program entirely from scratch. To do this, we have to learn how to intentionally pause our script and wait for a human being to provide the missing pieces. This is the first step in building a truly interactive application. Let's set up our workspace. On the left side of your screen, type your very first input command. Type the word input, followed by parentheses, and inside those, quote marks containing the phrase, enter your name. When Python hits this word, the program stops dead, and a blinking cursor appears. It waits for the user to press enter. But there is an immediate problem. If you type your name and hit enter, the data instantly vanishes. Your response is gone. The input command only asks the question. It does not remember the answer. To catch the user's response, we need a permanent storage container. We need to assign this input to a variable. Let's add name equals to the very beginning of our line. Now look at how the data moves. The user types Alex into the temporary terminal prompt. They hit enter, and that text travels across the equal sign, landing securely inside our designated variable. To prove we actually saved it, drop to the next line and write a simple print statement. Print, welcome, name. By pairing an input trigger with a variable container, you have just created a functional memory loop. Now let's expand our program. Drop down and write a second input command to ask the user for a piece of numerical data. Write age equals input, enter your age. Since age is a number, we should be able to do math with it. Let's write a quick test on the next line to add 5 to whatever the user types. Write age equals age plus 5. Look at this red text in the terminal. This is a type error. If you try to run that math equation, your program will crash. The system is complaining that it cannot add a mathematical number to a string of text. This reveals the most critical hidden rule of user inputs. Python assumes absolutely everything typed into a terminal is raw text. Even if you type the digits 2 and 5, Python just sees text characters. To fix this, we use a function called int. This tool strips away the text formatting and converts those characters into a real mathematical number. Let's apply it safely. Go back to your age variable. Wrap the entire input command inside the int function. It looks like this: int, open parentheses, your standard input command, and a close parentheses. Pay close attention to the end of this line. A very common beginner mistake is forgetting to close all open parentheses. Because we nested an input inside an integer function, you must have 2 closing parentheses at the very end. Mastering this specific translation step is what allows a program to actively compute and make logical decisions, rather than just acting as a digital form. Let's finish the build. Delete your temporary math test. We will assemble the final 4 lines of our student introduction project: 2 variables for our inputs and 2 print statements to display the results. Double-check your syntax. Ensure that the instructional prompts inside your input commands are properly enclosed in quotation marks so the user knows exactly what to type. Now hit run and watch your split-screen workspace. The terminal halts. It asks for a name. You type it in. It halts again. It asks for an age. You type the digits. Finally, the program pulls from those 2 distinct variable types to output a perfectly personalized greeting. By layering multiple inputs like this, you create the scaffolding for a highly customized user journey. Look at your terminal. By adding these interactive lines, you have transitioned from static scripts to building software that adapts to whoever is using it. To lock in these structural habits, click the link in the pinned comment below. I've left practice questions there so you can drill these syntax rules into your muscle memory. Now that you know how to collect raw numerical data from a user, what equations can you build with it? In our next module, we will answer exactly that by exploring Python operators. Keep practicing. Learning to collect and store data is the foundation you'll need to build the complex logic real-world tools we'll cover in the rest of this course. See you in the next lesson.